Hi, welcome back to geometry. Let's move on and learn about some trig ratios. By the angle-angle similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with that same acute angle measure. So these triangles below all have a 32-degree angle, which makes them all similar because they are right triangles. So we have this similarity statement. Therefore, we know that BC is to AC as EF is to DF, and that YZ is to XZ. These are all trigonometric ratios, which is a ratio of two sides of a right triangle. There are three different trig ratios you need to know: sine, cosine, and tangent. Each one has a ratio that you must remember. You have the sine of an angle, so sine of angle A is the opposite over the hypotenuse. The cosine of angle A is the adjacent side over the hypotenuse. And the tangent of angle A is the opposite over the adjacent. If you can identify the reference angle, label the opposite side, the adjacent side, and the hypotenuse, and then remember these trig ratios, you can't miss. It's easy from there. But if you're having a hard time remembering these ratios, take a look at this video. It might help you remember.
Math. Math. I wanna find the sine of this here angle C. Sine is the opposite over the HYP. I love it. Now let's find the cosine to work out the next part. Adjacent over HYP. Now that's the way to start. So, gato. Well, let's get the sine. Take H into O. So, gato. Well, let's get the cos. Take H into A. Get the tan, now get the tan of angle C. We are all in love with math. Get the tan, now get the tan of angle C. We are all in love with math. Tangent is O over A. Math. Tangent is O over A. Math.
Now that you've seen the video, to help you remember the different ratios, here's another way you could remember as well. As in the video, you saw SOHCAHTOA. And it's called SOHCAHTOA because now you might also think, but SOHCAHTOA is such a weird word. How can you remember how to spell it? So you can remember this phrase: some old hippie caught another hippie tripping over apples. If you can remember that phrase, that can help you spell it, and if you know what each letter stands for, you can't miss on the trig ratios. So let's give it a try. We need to write the trig ratios as a fraction and as a decimal to the nearest tenth. So for notice, we're all talking about angle J. So we're going to mark angle J. We're going to label the opposite side, the adjacent side, and the hypotenuse. The sine, remember, is the opposite over the hypotenuse. So now we just plug in our values, which is 60 over 61. So there it is, a fraction. You can type 60 divided by 61 in the calculator, and you get that it's about 0.98. The cosine of the angle is the adjacent over the hypotenuse. So when we plug in these numbers, we have 11 over 61. Type in the calculator 11 divided by 61, and we get that it's approximately 0.18. Now the tangent of angle J is the opposite over the adjacent. So we have 60 over 11. Type 60 divided by 11 in the calculator and we get that it's about 5.45. These are the trig ratios all for angle J. Oh look, we can also tie in our special right triangles to our trigonometry. They want us to write the cosine of 30 degrees as a fraction. Well, first we need to draw a 30, 60, 90 right triangle. Label our 30, label the 60, and if you remember on your formula charts, across from the 30 is s, across from the 60 is s square root of 3, and across from the hypotenuse is 2s. And since we want the cosine of 30, we know we're referring to this angle here, so we can label opposite, adjacent, hypotenuse, and if we want cosine, we know that's the adjacent over the hypotenuse. So we have s square root of 3 over 2s. Look to see if you can simplify it, and in this case we can. The s's cancel out and we're left with the square root of 3 over 2. And you're done. The cosine of 30 degrees is the square root of 3 over 2. Now it's your turn to try. But this time, you're going to be using a special right triangle with a 45, 45, 90. So make sure you draw and label your 45, 45, 90 and then give it a try. Find the tangent of 45 degrees. So pause the video now and give it a try. Okay, let's see how you did. Hopefully when you drew your triangle, you have your 45, 45, you have s, s, s square root of 2. And since we want the tangent in 45 degrees, here it doesn't matter which angle you pick, so just pick a 45, label opposite, adjacent, and hypotenuse. Using your SOHCAHTOA, we know the tangent is opposite over adjacent, so we have s over s, which is 1. So the tangent of 45 degrees is 1. Make sure you got this answer. If not, refer back to the examples to make sure you understand how to do it. Now hopefully you noticed when we did these that the tangent could be greater than 1, but the sine and cosine are not. This is why. The hypotenuse is always the longest side of a right triangle, so the denominator of a sine or cosine ratio is always greater than the numerator. Therefore, the sine and cosine of an acute angle are always positive numbers less than 1. But since the tangent of an acute angle is the ratio of the lengths of the legs, it can have a value greater than 0. So keep that in mind as you're trying to find these ratios. If you get that tangent is greater than 1, that's okay, because your numerator may be bigger than your denominator. But remember, that only happens with the tangent. So now if you notice, they want us to find the length of BC. We know we have an acute angle of 15 degrees. We have the opposite side, the adjacent side. Well, which of the trig functions in SOHCAHTOA uses the opposite and the adjacent? If you will notice, that is the t, tangent. So we're going to have the tangent of 15 degrees So if you notice, they want us to find BC. Well, we have a 15-degree angle, we have the opposite side, and we have the adjacent side. So hopefully, if you're thinking about SOHCAHTOA, you stop and think which one has the opposite and the adjacent. And you notice tangent does. So we're going to use the tangent of 15 degrees equals the opposite over the adjacent. So let's plug in what those values are. We know that the opposite side is 10.2. The adjacent is what we're trying to find. Now you may be going, how do we solve this? But if you remember, I can put anything over 1 and it not change the value. Now it looks like our proportions we did with similarity. So by doing so, all we can have to do is cross multiply. So you have x times tangent of 15 equals 10.2. And to get x by himself, we do tangent of 15 on both sides. That leaves us with x equals, now you just do it in the calculator. But make sure that your calculator is in degree mode. So you hit the mode button, make sure degree is highlighted, and then you're set to go. So you type in 10.2 divided by tangent 15, close your parentheses, and you get that x is approximately 38.07 feet. That is the length of BC, 38.07 feet. So you can see we're now tying in our proportions into our right triangles in trig as well. So just remember to label your triangle, set up your equation, put it over 1, cross multiply and solve. So now it's your turn to try. Oh, but beware, if you notice, we did not round until the very last step. You use the values that you're given, you type in the trig ratio or the trigonometric function, and you do not round until the very end. So now I want you to give this a try. Here's my little hint. I'm going to write my SOHCAHTOA up here to help you remember which one you need. So if we're trying to find QR, make sure to label your opposite, adjacent, and hypotenuse and determine which one you need. So do that now. Hopefully you recognized that here's my opposite, here's the adjacent, here's the hypotenuse. You notice you have the opposite over hypotenuse and realize you need the sine of 63 degrees, which is opposite over hypotenuse. So you have sine of 63 equals x over 12.9. Did you get this equation? Good. Remember to put the function over 1 and cross multiply. 1 times x is x, and you have 12.9 times the sine of 63. Type it in your calculator, and you get x is approximately 11.49 centimeters, which is the length of QR. Pretty simple, huh? Well, now let's take a look at this situation. The Pilatusbahn in Switzerland is the world's steepest cog railway. Its steepest section makes an angle of about 25.6 degrees with the horizontal and rises about 0.9 kilometers. To the nearest hundredth of a kilometer, how long is this section of the railway track? What you need to do now is to draw the picture. So pause the video and draw your picture. What you should have drawn was a right triangle that makes an angle of about 25.6 degrees and is about 0.9 kilometers above the ground. It's wanting us to find the length of the track. So now you notice we can label our opposite, adjacent, and hypotenuse and realize we're dealing with O and H, which is the sine. So we want the sine of 25.6 degrees, which equals 0.9 over x. Put your function over 1 and cross multiply. X times the sine of 25 equals 0.9. Divide both sides by sine of 25. Notice I have not typed anything in the calculator yet because we want to round at the very end. And we get x is approximately 2.0829 kilometers. And since it said round to the nearest hundredth, we're going to have an answer of 2.08 kilometers. That's all there is to trig ratios. Thank you and have a great evening.